Today we'll see a minimization algorithm. Here in using this example, here you can see the automata, finite automata, transition diagram for finite automata. So what we have to do is how to minimize this. So basically you check out how many states are there in this. There are A, B, C, D, E, F, G, H are the states. So minimization is used basically to remove the states which are not reachable from the start state. So what we are doing here is, in step 1, take one final state and one non-final state and put an X in the box. First we have to draw a table like this. This is a tabular method we are going to use. This is a table which we have to draw. When we are writing this, all the states we have mentioned here. Now the step 1, what we are going to do is take one final state and one non-final state and put an X in the box. That is, suppose for example A is a, in this figure you can see A is a non-final state and C is a final state. B is a non-final state, C is a final state. So first we will take A is a non-final state, C is a final state. So we will put a cross mark or X in the box which is having A and C, which is related to A and C. So we are going to put X in A, the box related with A and C. Here we are going to put an X. Next, B is a non-final state and C is a final state. Then C is a final state, D is a non-final state, C is a final state, E is a non-final state. Then C is a final state, F is a non-final state, C is a final state, G is a non-final state, C is a final state, H is a non-final state. So we have kept all X wherever it is a final state and non-final state. So what we have to do is, see the steps. Take one final state and one non-final state and put an X in the box. So A is non-final state and C is a final state. So put an X in the box where A and C intersect. Similarly, put an X for intersection of B and C. Repeat for all pairs of final and non-final states. Now what we have to do is, we have to find all pairs such that del of R comma A equal to P and del of S comma A equal to Q so that what we have to do here is, if P and Q already have an X or an entry in the table, then R and S also have an entry. So we have to check out all the pairs. For this, what we are going to do is, we are going to find out all the pairs of R comma A and S comma A where we are getting P and Q. Means P and Q will have already an entry. Then we have to put an entry for R comma S also. Now we are finding pairs like del of A comma 0 we get B, del of B comma 0 we get G, del of C comma 0 we get A, del of D comma 0 we get C, del of E comma 0 H, del of F comma 0 C, del of G comma 0 G, del of H comma 0 G. Now we find that which already are having. Now we will see that B and C, does it have this one entry or not? Yes, B, C is having an entry. That is, we have to see this one, B and this C is having an entry. You can see here B, C C is having an entry. So we say take these two pairs. What are the two pairs? Del of A comma 0 and del of D comma 0. So because del of A comma 0 equal to B, del of D comma 0 equal to C. Del of A comma 0 equal to B, del of D comma 0 equal to C. Because these two already have an entry, then A comma D also will have an entry. A, D will also have an entry. So we put an X here also. Okay. Next we find out different pairs. Now we will see A, C. This one you see. This one A and this one C. AC is already having an entry. So CF also has an entry. So we write del of C comma 0 equal to A and del of F comma 0 equal to C. And this you can see, this one is having an entry already. AC is having an entry. So CF also will have an entry. CF already has an entry, so no need. Similarly, you find out other pairs also. Like you have G, then AC is over, GC you check out. Yeah, GC you check out. Then when this G and C you can check out. G and C means it is leading, what you are getting, del of B comma 0 equal to G, del of D comma 0 equal to C. GC is having an entry or not, you see. GC is having an entry, you can see. Yes. So GC is having an entry means BD also will have an entry. BD also has an entry. BD also has an entry. Similarly, find out all the pairs which already have an entry. Now you check out H and C also. You can check out for H and C also. H and C means it is giving you del of E comma 0 equal to H, del of F comma 0 equal to C. H comma C. Is H comma C having an entry? Yes. H comma C is having an entry. Then your E comma F also will have an entry. So here we have kept an entry for E, F. Okay. Now next we will check out for this one, BC over AC over GC over HC over. Then we can check out for EF or EC, del of E comma 0, it is giving you H, okay, del of G comma 0, that is also giving you H. Now we will find out similarly for del of A comma 1, del of B comma 1, del of C comma 1, del of D comma 1, del of E comma 1, del of F comma 1, del of G comma 1, del of H comma 1, and we will find out the pairs which already have an entry. One easy method here is we can find out one non-final state and one final state because they already have a entry. So we can check out now. See, F and C already have an entry. So A comma B also will have an entry. So in this, A, B will also have an entry here. Okay, next. This one is done. Next one is G comma C is also having an entry. G comma C is having an entry. C comma D also has an entry now. C comma D also will have an entry. This is already having an entry already. Next one is C and G. If we take C and G also has an entry, CD also has an entry. Now we will see FC. FC means we are getting E comma 1 is F, del of C comma 1 is C. Now if FC has an entry, then EC also has an entry. It already has. Okay. Then we see if GC has an entry, DC also has an entry. If EC has an entry, then GH also should have an entry. If EC is already having an entry, so GH also should have an entry. GH also will have an entry. Done. Similarly, you find out the pairs from here and here, and you will find that all the pairs, all the boxes are filled up except few boxes which are not filled up. So you can say that, see now we have got in the table, you can see that HG has got an entry. So here we have to see HG, this two you see, these two pairs, HG, it has got an entry now. So we can add up an entry for EG. Because HG has got an entry, we can put an entry for E and G also. Now, similarly, we have to check out for other entries also. Now, we already have got an entry for E comma G. Then automatically G and F also will have an entry, because we got an entry for E and G. Then you will get an entry for G and F also. So, GF, you can put it here, right? We got an entry for G comma GF. We got an entry for GF also. You can see here, we got an entry for GF. Then automatically we get an entry for DE also. Okay. Next we will find some more. Now we see CF already has an entry. So B comma E also will get an entry. E also will get an entry. So now we check out all the pairs which already have an entry, and then we write in the X there. Now in this case you can see that FG already has an entry. So AD also will get an entry. It is already there. Okay. So AD is already there. So we can find out, easy method is, what we have to do is, we have to see this table, find out wherever x's are there, that pairs you find out in their del functions here outside. So automatically this will come into this one, boxes. The x will come into the boxes. So now next one, C and G. C and G has an entry. Then this is B comma 1 is also C. Here you can see B comma 1 is also C. So B comma 1 we are taking. So B comma 1 is equal to C and F comma 1 equal to G. So if C, G has an entry, then B, F also should have an entry. So B and F also should have an entry here. Okay. So now we see here G has an entry and C has an entry. So del of F comma 1 is G and del of H comma 1 is C. Already G and C has an entry. Then F comma H also will have an entry here. Okay. Next you see C, del of D comma 1 equal to C and del of G comma 1 equal to E. So C comma E is already having an entry. Now D comma G also will have an entry. So here B comma G also will have an entry here. Okay. Next you see del of D comma 1 equal to G and del of G comma 1 equal to E. So G and E already have an entry. E G is already having an entry. So automatically DG also will have an entry. DG also will have an entry here. DG also will have an entry. Okay. Next we try to find out some other pairs. Now F comma C is already having an entry. So E comma H also will have an entry. So E comma H. This E and H will have an entry. EH will have an entry. What we have to do is, the simplest method is, you see which squares are empty. Whichever squares are empty, you try to find here whether there are any pairs which are there here. So if there is an entry for these outputs, we can put the entry for those also, related R comma S. Next we see that del of D comma 1 equal to G and del of H comma 1 equal to C. That means G and C already have an entry. This G and this C, the last one, C already have an entry. Then you can have an entry for this D and this H. Okay, D and H can have an entry. So DH will have an entry over here. Okay. Next, now we see that, we see the last one, del of A comma 1 equal to F and del of F comma 1 equal to G. So FG is already having an entry. You can see here FG already has an entry. FG has an entry. FG has an entry. So automatically this AF also will have an entry. You can see AF also will have an entry over here. Okay. See here, E, that is del of G comma 1, and the first one, del of A comma 1 F, and that means E and F has an entry, then automatically A and G will have an entry, because EF already has an entry. E, you can see here, EF already has an entry. Then we can have an entry for A comma H. Sorry, it is A comma G, because E and F we I've shown you E and F. So it is A comma G will have an entry. Here A comma G will have an entry. Next we find out because F is having an entry, C is having an entry, then A comma H also will have an entry. So we have kept A comma H also is having an entry. So what are remaining things we will see here. Now we see that few of the states, few of the boxes are left empty. Which are the boxes which are left empty? A, E is left empty, B, H is left empty, and D, F are left empty. So first let us check A and E. What is the result of that? A and E. If you see in all these things, A, del of A comma 1 equal to F, and del of E comma 1 equal to F. So these are equivalent states. So we can write them as A is equivalent to E. A is equivalent to E. And next one we see BH. Here if you see, del of B comma 1 equal to C and del of H comma 1 equal to C. Both are same. So we can write B is equivalent to H. And next one is D comma F. So if we see D comma F, here we see D comma 1 equal to G and F comma 1 equal to G. So D and F are equivalent. So we find these three states. So we can put them together in one state as one state.